Math assignment number 5. This is going to be a review of everything that we've covered in the first 4 videos. There's 20 questions, and it looks like I'm going to break that up into 2 videos because this might be a little long. Now that I've explained things in previous videos, this will go a lot faster though. So, question number 1, convert 78 degrees Celsius to Fahrenheit. Degrees Fahrenheit. Okay. I'm going to refer to the ABC formula conversion tables, or the ABC math formula sheet, which is what I call it a lot. Let's write down the first formula. We're looking for degrees Fahrenheit equals degrees Celsius multiplied by 1.8 plus 32. We'll rewrite that equation with all the information in the question. Degrees Fahrenheit equals 78 degrees Celsius multiplied by 1.8 plus 32. I used the wrong color pen, didn't I? That's all right. We'll go back to the blue. Let's multiply this out. 78 multiplied by 1.8, that equals 140.4 plus 32. The solution will be in green. And that equals 172.4 degrees Fahrenheit. The best answer is C. Question number 2. Convert 213 degrees Fahrenheit to Celsius. Degrees Celsius. Our formula is going to be, let's start out with degrees Celsius equals degrees Fahrenheit minus 32 divided by 1.8. Well, let's rewrite that equation, including this information in the question. Degrees Celsius equals 213 degrees Fahrenheit minus 32, divide that by 1.8. Let's do the math. 213 minus 32 equals 181 degrees Celsius equals 181 divided by 1.8. Divide that by 1.8 and we get 100.56 degrees Celsius. If we round that up, we'll have 101 degrees Celsius. The answer is B. Question number 3. What is the pressure in PSI at the bottom of a tank if the water level is 33.11 feet in depth? I like how they use depth. What is the pressure in PSI? That's what we're looking for. Now we know that there are 0.433 PSI per foot. How do we figure out how to get that? Well, the pressure, we'll do PSI equals we'll call depth of 33.11 feet And we'll multiply that by 0.433 psi per foot. Now what we're going to do here is we want to cross cancel out the feet so that we end up with psi. So I'm going to add this 1 there. Foot over 1 is the same as foot. What that allows me to do is cross cancel. Cross cancel out these 2 feet. That leaves us with psi, which is the unit of measure we're looking for. .11 multiplied by 0.433. That's going to give us 14.34 psi. The best answer is B. Question number 4. The pressure head at a fire hydrant is 195 feet. Calculate the pounds per square inch. We're going to calculate the PSI. Let's write down our formula. PSI equals, now the pressure head, same thing as height or depth, so we'll call it head pressure, 195 feet. We know there's 0.433 psi per foot. We want to cross cancel to eliminate the feet, so I'm going to put that over there. Take out that foot, and that leaves us with 195 times 0.433 equals 84.44 psi. This is psi because I eliminated feet here. I've got psi. That's the unit of measure we're looking for. The answer is A. Question number 5. Find the area in square feet for a rectangular shaped basin, 821 feet in length and 75.5 feet wide. We want the area in square feet. Our formula is area equals length times width. Let's rewrite the formula with all these factors. Now we want the area in square feet, so we will put area in square feet equals the length. The length is 821 feet. The width is 75.5 feet. Let's do our calculations. And this looks right because I have this unit of measure foot, that unit of measure foot. 1 plus 1 is 2. This is square feet. So let's do our calculations. 821 multiplied by 75.5, and that equals 61,985.5 square feet. The best answer is D. Question number 6. Calculate the volume in cubic feet of a trench, 417 feet in length, 12.5 feet wide, and 8 feet in depth. Calculate the volume in cubic feet. Volume is equal to length times width times depth, or height. So let's rewrite that equation with these factors. We want volume, and we want it in cubic feet, equals length, which is a trench 417 feet in length, we have a width, .5 feet, and we have depth, which is 8 feet. I have feet, feet, feet. That's going to give us cubic feet. We'll multiply this out. 417 multiplied by 12.5 times 8. 41,700 cubic feet. The best answer is B. Question number 7. What is the volume in gallons for a pipe 36 inches in diameter and 315 feet in length? It's a good sized pipe. Sounds like a gravity sewer. What is the volume in gallons? That's the question, isn't it? That's what they want us to determine. So, volume equals, and now this is a giant cylinder. This has a diameter. So when we're working with circles, when we're working with cylinders, we're going to use a certain factor. And that factor is going to be .785. We're going to multiply that by the diameter squared, or diameter times diameter. We're also going to multiply that by the length, this is the formula we're going to use. Now I'm going to add something onto that formula, which is not in the math formula sheet, but the conversion is 7.48 gallons per cubic foot. So what we're doing here, by multiplying these across, we're getting the volume in cubic feet. To get gallons, we have to multiply it by this factor. I'm going to go ahead and add it here. Okay, now this is an interesting part here, because this unit of measure, inches, is not the same as feet. And I want to get to feet. So I need to convert 36 inches to feet. How do I do that? Well, there are 12 inches in a foot. So if I take 36 inches and divide that by 12 inches per foot, I will get, and keep with me here, I have a dividing line here. This is division. I can cross cancel, take out this inch, take out those inches, and now I'm left with 36 divided by 12 equals 3. 3 feet. That's the unit of measure I'm looking for. So this pipeline is 36 inches in diameter, which is 3 feet. All right, let's rewrite this formula with all the proper variables. We want volume, and we want it in gallons, of a pipe, which is a cylinder. We're going to multiply 0.785 by the diameter, and that's 3 feet. And then we're going to multiply it again by the diameter. Now we want the length. And the length is 315 feet. And now we need our conversion factor. 7.48 gallons per cubic foot. I've got gallons here. This is what I'm looking for. I need to eliminate feet, and feet, as well as cubic feet. How am I going to do that? Well, I'm going to put in a dividing line, put these feet over 1, and let's cross cancel. It's 1, 2, 3. That eliminates that. Those are cross canceled. Let's do our multiplication here. Oh, and by the way, here's gallons. It's the only one left. That's the unit of measure we want. 0.785 times 3 times 3 times 315 times 7.48, and we get 16,646.55 gallons. We can round that up to 17,000 gallons. The answer is B. Question number 8. A tank is conical at the bottom and cylindrical at the top. The diameter of the cylinder is 39 feet with a depth of 70 feet, and the cone depth is 12.3 feet. What is the volume of the cylinder in cubic feet? We want volume, and we want it in cubic feet. We have a cylinder, and underneath that cylinder, I'll just draw it separately, is a cone. They're attached. They're open at these ends, so it's one big tank. All right. Now, the question is, what is the volume of the cylinder in cubic feet? Well, the volume of the cylinder, that means I'm not concerned with the cone. You have to pay attention to these things before you get into, or while you're trying to solve. You want to make sure that you're not solving for both, because I'm sure the answer is going to be there for both pieces. What's the formula? The formula is, for a cylinder, we want volume equals 0.785. We're going to multiply that by the diameter times the diameter times the height and that's going to give us the volume. So let's rewrite that equation for this question. We want volume. We want it in cubic feet. This is a cylinder. 0.785. We're going to multiply that by the diameter. And the diameter of the cylinder is 39 feet. We're going to multiply it by the diameter again, just like it says here. 39 feet. And then we need the height. In this case, it's the depth. $70 feet. Let's make our calculations. 0.75 multiplied by 39 times 39 times 70. Is that the correct answer? Well, let's check our cross cancel, or let's count our units. Excuse me. We have foot, foot, foot. 1, 2, 3. Checks out. We've got our unit of measure that we were looking for. The answer is 83,578.95 cubic feet. Let's look at our choices. C. C is the correct answer. Question number 9. What is the volume in gallons for the trench in question 6? I'm going to go back to question 6. Question number 6. The volume in cubic feet is 41,700. So what is the volume in gallons? Why do we need to know how many gallons the trench will hold? Well, in my line of work, when there's a force main break or a water main break, that's the pipe that's underground. It's either full of water or full of wastewater. Once we've identified where the leak is, we have to dig a trench. We have to expose the pipe where the break is. While we're in the field during the repair, we do very quick calculations, and you'll see right here it just takes a few minutes to determine how much water we can hold in that trench as we bring in pump trucks and hydrovac trucks to move the water out during the repair, so that our contractors can get in and make the repair. So volume in gallons for a trench. This is a rectangular trench. We want volume equals we already have volume in cubic feet, and we're going to multiply that by 7.48 gallons per cubic foot. This is our conversion, 7.48 gallons for every cubic foot. This is going to be our equation. Let's rewrite it. We're looking for volume in gallons equals volume of the trench is 41,700 cubic feet, and we're going to put that over 1. We're going to multiply that by our conversion of 7.48 gallons per cubic foot. And if you're following along, you can see how I'm going to cross cancel now. I'm going to get rid of this cubic foot and that cubic foot and leave me with gallons. How am I going to do that? This is a division line. This is a division line. This one is over it. This one is under it. That leaves me with gallons. That's the unit of measure that I want. 41,700 multiplied by 7.48 gallons per cubic foot, and we get 311,916 gallons. The answer is D, 312,000 gallons. We're already at question 10. We're doing really well, so let's just keep moving. A circular tank has a radius of 15 feet and is 20 feet in height. What is the capacity of the tank in cubic feet? What is the capacity of the tank in cubic feet? Capacity is another word for volume. And cubic feet will be expressed as foot cubed. Let's write out the equation. We want volume is equal to, now this has a radius, it's a cylinder, we're going to use 0.785. We're going to multiply that by the diameter times the diameter times the height. That's our formula from the ABC math formula sheet. Let's rewrite this formula with all the information we have in the question. Volume, let's make that a comma there, in cubic feet of a cylinder equals 0.785 multiplied by the diameter. Now, the radius is 15 feet. Just for those of you who may not have seen an earlier video, this is a circle. The center is here. From the center to the furthest edge is a radius. Whoops, almost didn't spell it correctly. If I go from one edge through the middle to the other side, this is the diameter. Now this question is asking for the diameter. Okay, so if the radius going across is 15 feet, what is it going? That's just to the middle. That's the radius. What's the length going all the way across? Well, 15 feet, another 15 feet, that's 30 feet. Right? So the radius plus the radius equals the diameter. Let's write that down. The diameter is 30 feet. We're going to multiply by the diameter again. .30 feet. And now the height. The height is 20 feet. We have a foot here, a foot there, a third foot there. We're looking for cubic feet. We're on the right track. We're going to get the answer, the correct answer. 0.785 times 30 times 30 times 20, and that gives me 14,130 cubic feet. Oh, the correct answer is A. A is the most correct answer. We've gotten through through those first 10 questions very, very quickly. We're going to move on. I'm not going to make this a double video. I'm not going to make it a two-part video. Question 11, find the area in square feet for question 10. The area in square feet for question 10. Let's look at question 10. Now let's go ahead and write out the formula. Area, and this would be a circle because remember, in question 10, this is a circular tank with a radius of 15 feet. We've already calculated that the diameter is, the diameter is 30 feet. So area equals 0.785 multiplied by the diameter times the diameter is going to give us square feet. Let's rewrite this. Area in square feet equals 0.785 multiplied by the diameter, and this is 30 feet, multiplied by the diameter again. We have a foot here, which makes square foot. That's the unit of measure we're looking for. Let's do the math and solve. 0.785 times 30 times 30. The area is 706.5 square feet. B is the correct answer. The most correct answer. Question number 12. Convert 31 degrees Fahrenheit to degrees Celsius. So we want degrees Celsius equals degrees Fahrenheit minus 32 divided by 1.8. Let's rewrite that formula with this factor. Degrees Celsius equals 31 degrees Fahrenheit minus 32 divided by 1.8. Now let's take 31, subtract 32, and that gives us -1 divided by 1.8 divided by 1.8, and that gives us a -0.56. The best answer is C. All right, question 13. How many gallons are in 4,127 cubic feet? It wants to know gallons. We want volume in gallons equals, and I'll go ahead and write out the equation. We have volume 4,127 cubic feet, which is here. We're going to multiply that by our conversion factor, 7.48 gallons per cubic foot. Now let's cross cancel. Well, to cross cancel, I need to get rid of this cubic foot and this cubic foot. I put that division line over 1. Now we have cubic foot, they're gone. Gallons, gallons. Let's run our calculations. 4,127 times 7.48. That gives us 30,869.96 gallons. The most correct answer will be 30,000 gallons. Question number 14. Find the area in square feet. Find the area in square feet. For a rectangular shaped basin measuring 85 feet long, 65 feet wide, and 33 feet deep, we want area equals length times width times height. It gave us the height or the depth, but we don't actually need it, do we? Because we want the area. So I'm going to take out the height, and I'm leaving this here. I'm not going to reshoot this because I want you to see that things happen. Sometimes you make slight mistakes that shouldn't trip you up. We want the area. It's going to be in square feet. We have area equals length times width. We'll rewrite the equation with the proper factors. We want area, and it'll be in square feet. We want the length. The length is 85 feet. We want the width. The width is 33 feet. Let's calculate that out. 85 multiplied by 33, that gives us 2,805 square feet. Well, is it closer to 2,000 or 3,000? That's an 8. Anything 5, 6, 7, 8, 9 in that spot right there, in the thousandth spot, we're going to round up to 3,000. 3,000 is the most correct answer. 6 more questions to go. We're killing it. Question 15. 2 columns of water are filled completely at sea level to a height of 88 feet. Column A is 5 feet in diameter. Column B is 50 feet in diameter. What will the 2 pressure gauges, each attached to the bottom of each column, read? Now, in a previous video, I explained that it doesn't matter what the diameter would be. In fact, this one is 5 feet. The second one is 50 feet in diameter. Doesn't matter if it's 5 feet or 50 feet in diameter. What matters is the water depth. From the water level all the way to the bottom. It's the pressure from the top being pushed down on the bottom in a direct line. So, let's write our formula. The point is, only thing that matters to a height of 88 feet. The diameter doesn't matter. This diameter does not matter. So we want to determine the pressure equals depth or height, and that is 88 feet. And we know there are 0.433 psi per foot. We have to get rid of the feet because we want psi. So I'm going to put a division line there, put the foot over 1, remove this foot, remove that foot. That leaves us with psi. That's the unit of measure we're looking for. Now it comes down to the math. 88, multiply that by 0.0433, and we get 3.81 psi. Whoop. I missed. It's not even a choice. 88 feet times 0.04. Nope, that's what I did wrong. 88 multiplied by 0.433. Come on. 88 times 0.433, and that equals 38.1 psi. The answer is 38, or D. I make mistakes. It's fun in front of my classrooms when I'm doing a lecture, because my students, the ones who are a little better or more comfortable with math than me, are very quick to point it out, and I appreciate it. I want to be called out. I want people to know that I make mistakes, and they don't have to trip you up. You'll catch yourself. You double check yourself. You make sure that you're getting to the right answer. This is going to happen. This is real life. All right. Question 16. Find the volume for a tank 110 feet in diameter and 40 foot in depth, or 40 foot deep, in cubic feet and in gallons. So we want to find the volume in cubic feet and gallons. Volume equals, and this is got a diameter, so volume equals 0.785. That's in our formula, in our ABC math formula sheet, 0.785. We're going to multiply that by the diameter squared, which is diameter times diameter. We're going to need the depth, or the height. And because we want an answer in gallons, well, we're going to do cubic feet first, and then we'll do gallons. Let's rewrite the equation. Volume, and we're going to go in cubic feet. That's here. Equals 0.785 multiplied by the diameter (110 feet). We're going to multiply by the diameter again. 110 feet. Now we want the height. (40 foot deep). All right. Let's multiply this out. Let's see what our cubic footage is. Just to double check, we've got a foot here, a foot here, a foot here. We want cubic feet. All right. We're in good shape. 0.785 times 110 times 110 times 40, and that gives us 379,940 cubic feet. Now we want the same in gallons. So I could rewrite this all over again. I could say volume in gallons equals 0.785 times the diameter, 110 feet, times the diameter, 110 feet, times the height, which is 40 feet, And then we'll add our conversion factor, 7.48 gallons per cubic foot. And I write it all out again because I want to be able to cross cancel. I've got cubic foot here. I need gallons. The gallons are right here. So I need to get rid of this cubic foot. I'm going to put this foot over 1, that one over 1, that one over 1. I have 1, 2, 3 of them. That cross cancels this out. I'm left with gallons. This is the unit of measure we want. So let's multiply it out. 0.785 times 110 times 110 times 40 times 7.48, and that gives me 2,841,951.2 gallons. So here we're going to see that our only choice is A. We have 380,000 and 2.8 or 2,850,000 gallons. A is the correct answer. It's the best choice. Question number 17, convert 212 degrees Celsius to Fahrenheit. Well, it seems like we've done this. We know what we're doing. We always start with degrees Fahrenheit equals, let's refer to the math formula sheet, degrees Celsius multiplied by 1.8 plus 32. All right, let's fill this out. Let's rewrite this formula, adding the temperature in Celsius, 212 degrees Celsius. Multiply that by 1.8, then we'll add it with 32. Let's do the math. 212 multiplied by 1.8, that gives us 381.6, and we're going to add 32 plus 32, and that gives us 413.6 degrees Fahrenheit. Look at that. Oh, and the correct answer is 403. Cannot forget to answer the question. Question 18. What is the volume in gallons for a tank 45 feet in diameter and 15 feet in height? Volume in gallons. The formula we'll want to use is volume equals, and this is a tank that has a diameter, so it's circular. So we're going to use 0.785 and multiply that by with the diameter twice. Diameter times diameter, and then we're going to multiply that by the height. That's our formula. Now let's put in all the best information. Volume, and we're going to go with gallons, is equal to 0.785. The diameter is 45 feet. We're going to multiply it by the diameter again. Now we're going to multiply it by the height. And the height is 15 feet. We need to convert to gallons. We're going to use our conversion, 7.48 gallons per cubic foot. Now let's cross cancel. I need to get rid of these cubic feet. I have 1, 2, 3 of them right here. I just need to put them over 1. 1, 2, 3, get that. And now we have gallons. So let's multiply that across. 0.785 times 45 times 45 times 15 times 7.48, and that gives me 178,355.93 gallons. Looks like the closest answer is A, 180,000 gallons. Question 19. If a tank holds 1,273,421 gallons, what is the volume in cubic feet? Well, that's a good question. If the volume of the tank is 1,273,421 gallons, and I know there are 7.48 gallons per cubic foot, then let's divide that. 7.48 gallons per cubic foot. Now, we want our answer to be in volume cubic foot. Let's cross cancel. I have to get rid of these gallons because I want cubic feet. So I will put a dividing line over this, or under a gallon. So we have a gallon over the dividing line with a dividing line in between them. I can cross cancel out these gallons. I'm left with cubic feet. That's the unit of measure I want. So we have 1,273,421. 1,273,421 divided by 7.48, and that's going to give me 170,243.45 cubic feet. The answer is B, and very clearly too. The last question, when we're done, look at the time, see how long it took to do this. Before I do the last question, please like my video. It helps me out. I have a career, but this is my business. This is my second stream of income. I'm 54 years old, got to retire in the next 20 years, I hope. Please like the video. If you like what I'm doing, please subscribe. There's a lot more videos coming. Leave a comment, ask a question. I work 50, 60 hours a week sometimes. I'm going to do my best to answer the comments, answer the questions. You'll find a link. It goes to my website. The website, I sell all the lessons, all the answer keys as a download. It's very affordable. You also have links to the ABC website where you can download the math formula sheets for free. I get nothing from it. Click on those links, you can get your math formula sheets. All right, question 20. What is the pressure at the bottom of a tank, 45 feet in diameter, 75 feet in height, with a water level of 50 feet? What is the pressure at the bottom of a tank? In previous videos, you've heard me tell you, it doesn't matter how high the tank is or how tall it is. What matters is the water level. This is what determines what the pressure is at the bottom. Our formula is PSI equals 0.433 PSI per foot multiplied by the water depth. The water depth is 50 feet. We're going to put that over 1. Let's cross cancel. We want to eliminate the feet because we want our answer to be in PSI. This foot is below the dividing line. This foot is above the dividing line. That leaves me with PSI, which is what we're looking for. Let's do the math. 0.433 times 50, and that gives me 21.65 psi. The answer is D. Thank you. That went quickly. We got through all 20 questions in one video. Very happy about that. Stick with me for the next part of the series. We'll get through that together and it'll make sense.